number 25, division. This is long division. We can take x plus 5 and divide it into x squared plus 8x plus 15. This is long division. Now what we're going to do is we're going to take what times x, or this first term here, gives me this first term down on the bottom. So x times x gives me x squared. Then at that point, you're going to distribute that to both of these. So not only are you going to multiply x times x, you're going to multiply x times 5, which gives you 5x. So you don't look at what's here to determine what you're going to put here. You only look at the first term. And then at that point, you're going to subtract. And when you subtract a binomial, you got to distribute the negative sign into the parentheses. So this becomes a negative x squared and a negative 5x. So when I start going through this, I'm basically just going to go in and change the signs, because that's what subtraction does to a binomial or a polynomial. So here, x squared minus x squared is 0. 8x minus 5x is 3x. Bring down the 15. Again, we're going to look at what times this first term, x, is going to give me that 3x. Well, I've already got the x, so I need a positive 3. So I'm going to multiply positive 3 times x gives me a positive 3x. I got to multiply that positive 3 times the 5, gives me a positive 15. And then I'm going to subtract again, which basically just changes the signs. So 3x minus 3x is 0. 15 minus 15 is 0. So there's no remainder. So my final answer is, what's up there? X plus 3. That's my quotient, my answer to my division problem. No remainder, so I don't have to worry about adding or subtracting the remainder. X plus 3 would be my answer. Here's another one. Let's take a look at it. I've got x plus 4 into x squared plus 9x plus 18. Look at that. What times that first term gives me x squared? Well, I need x. And then I've got to distribute that to here, so I get a positive 4x. Come down here and I subtract. Those 0 out. 9x minus 4x is 5x plus 18. So what times x is going to give me that 5x? Well, I've already got the x, so I need a positive 5. So I got positive 5 times x is 5x. Positive 5 times 4 is a positive 20. And then again, I'm going to subtract. So there's a sign that 5x minus 5x is 0. 18 minus 20 is a negative 2. So we have a remainder this time. So what we're going to do is we're going to write down the quotient x plus 5 plus, I always put a plus sign, and then I put a fraction, I put the remainder on top, it's the numerator, negative 2. The denominator is the divisor x plus 4. And that would be my final answer. Now it might have x plus 5 minus 2 over x plus 4. I don't usually put the minus here because depending on the sign. So basically I like to put plus and then put the negative on the top. Because if you end up with a binomial as a remainder, then that negative, if you put it here, goes to both the top, both numerators, terms in the numerator, so you don't want to do that. That's why I always put plus, then put whatever the remainder is. This one, they want us to factor. So we're going to factor by grouping. Now the reason why they say factor by grouping is because there's 4 terms. That's probably the easiest way to factor. What I usually do is I factor the first 2 terms if they have something in common. Now if they don't have something in common, you might want to rearrange the terms where they have something in common. Well, the first 2 here have an x in common, but not just one x, they have 2 x's. The first one has 3 x's, second one has 2 x's, so I'm going to pull out an x squared. Now when I do, I put what's left in parentheses. So I pulled out x squared from x to the third, I still have one more x left. Plus, I pull out an x squared from 6x squared, and I get a 6. Then I go over here and I look at, all right, what do these two have in common? Well, they're both divisible by 2. So I'm going to pull out a positive 2. When I do, I get x left in the first term. When I pull out a 2 out of the 12, I get a 6. Now what you should notice when you do factor by grouping is that what's inside the parentheses should be the same. If not, you might want to go back and look at what you factored. So you pull out that x plus 6, that's your first parentheses, and then you put what's left, which is the x squared and the positive 2, in the other parentheses. So x squared plus 2. And that would be your final answer. And if we wanted to check it, we could FOIL it or distribute and should come up with that answer. If we don't, then somehow we did something wrong. So you could check your work if you wanted to. Now this one just says factor completely. It doesn't tell you how to do it or which method to use. Now I like to use trial and error. Basically what I do, if it's just, if the number in front of the x squared is a 1, but you don't see it, it's just x squared. If that's the case, I always know my first terms are going to be x, because these two right here have to give me that first term there. So x times x is x squared. Now, what goes here? Well, factors of this number right here. Well, there's a lot of factors of 54. So what I would do is I'd look at 54 and I'd break it down. I know that I have 1 in 54. I have 2 will go into it 27 times. 3 will go into it 18 times. Let's see, 4 won't go into it, 5 won't go into it, 6 will because 2 and 3 will. So 6 goes into it 9 times. And then 7 won't and 8 won't. 7 times 8 is 56. So we're done. Because then we go right back up to 9, 18, 27, it's 4. Now the reason why I said trial and error is my favorite method in this case is because what I look at here is I look here. That's a negative sign. That means for that to become a negative, I have to have a positive and a negative here. Because a positive times a negative, because this is my last terms, these two red blanks here are my last terms, which gives me that number. So one's got to be a positive times a negative to give me a negative. So I know they're different. Now the other thing it tells me is I'm going to subtract these factors right here to get the middle term, negative 3. So I look here, which one of these factors, when I subtract them, gives me a 3? And that would be the 6 and the 9. Now, I didn't say whether it be a positive or a negative 3 because that comes now. Now what I'm going to do is I need a what? I need a negative 3. So if we remember the rules of integers, when you're subtracting, you keep the sign of the larger. So you got a 6 and you have a 9. Which one's larger? The 9. So guess what? That middle sign's got to go with that number. So it's got to be a negative 9. So since I already have the negative sign here, I need the 9 here and the 6 here. Then again, I can check it by just multiplying it out. X times x is x squared. X times negative 9 is negative 9x. 6 times x is a positive 6x. Positive 6 times a negative 9 is negative 54. Middle terms, combine those, we get x squared minus 3x minus 54. So did it match? Absolutely. So my final answer is x plus 6 times x minus 9. Now there are other ways to solve this, but to me that's probably one of the easiest methods, especially if the x squared has a 1 in front of it or doesn't have a number at all in front of it. It says factor completely. Now this is a binomial. it says 4x squared minus 9. Now the first thing I would do is look, does it have anything in common? Well, there's no common factor between these two. So now what I got to do, if it's a binomial, I need to look to see if it's a perfect square. Meaning, what would give me 4x squared? Well, 2x times 2x. It's a perfect square. And then 9. It's 3 times 3. So that's a perfect square. So what I'm going to do, it's called a difference of squares. My first term is going to be 2x times 2x. And my last terms are going to be 3 and 3. Now to get that last sign to be negative, one's got to be positive and one's got to be negative. And so that would be my answer. And we could check it. Again, double check your work. 2x times 2x is 4x squared. 2x times negative 3, negative 6x. Then we take that positive 3 times a positive 2x is a positive 6x. Positive 3 times a negative 3, negative 9. What happens? 6 is 0 out. I get 4x squared minus 9. They match? Right there. So my final answer is 2x plus 3 times 2x minus 3. That is a difference of squares. You should have learned the pattern in your lessons. Do you have to know that pattern? No. You just got to be able to recognize that they're perfect squares and factor them accordingly. This is solved by factoring and using principle of zero products. So again, it's going to be basically the same thing as what we just got through doing. The only difference is this time I have it equal 0. It's an equation, not an expression. Again, I'm going to use trial and error, A, and a lot of times my trial and error, there's really no error in it because my trial is I take 32, factors at 32, and I bring in 1 times 32, 2 times 16, 3 won't go into it, 4 will go into it 8 times, 5 won't go into it, 6 won't go into it, 7 won't go into it, so there's all my factors of 32. Now you can use your calculator to test them. If they don't go into it evenly, it comes out with a decimal, then it's not a factor. Now, the last term's positive this time. What that means is I'm going to add the factors to get my middle number. Well, which one of these, when I add them, I get a 12? Well, that would be the 4 and the 8. You may say, well, it's a negative 12. That's okay. Remember, if this last sign's positive, then what that tells me is the signs right here are going to be the same. You might say, well, what are they going to be? Well, that's where the middle term comes in. See that negative sign? If they have to be the same, they both have to be negative. Alright, so my signs are going to both be negative because a negative times a negative is a positive. Now, I'm going to take the 4 and the 8, I plug it in. Doesn't matter where the 4 or the 8 goes. And that's my final answer. Let's check it. A times A squared. A times negative 8, negative 8A. Negative 4 times A, negative 4A. Negative times a negative, 4 times 8, positive 32. Look at your middle terms, add them together, because they're the same sign. We're going to add and keep that sign, so negative 8, negative 4 make it negative 12A, positive 32. Does it match? Absolutely. Now that we've checked it, we got it all right. Now what we've got to do is we're not done. This is not the final answer. And this is where some people make their mistakes. They leave that as their final answer and they're not completely done. And so I only was able to give partial credit on the midterm for those who left it that way. Because what's the next step is you take this factor, a minus 4, you set it equal to 0, and you set a minus 8 equal to 0, because it doesn't matter which one's 0, because 0 times anything is 0. So if this set of parentheses becomes a 0, I multiply it times this, it's going to make it 0. So if either one of them are 0, then it's going to satisfy the equation. So I add 4 to both sides. So I get A equals 4. Add 8 to both sides, and I get A equals 8. So this would be my answer. A equals 4 and A equals 8.